అయ్యో ఎంటర్ చేసేయండి.
Good evening. Welcome to Unacademy and YouTube channel. Today I will be discussing MSQs and NAT questions on differential equations. I will be discussing MSQs and NATs of differential equations. Let K comma L belongs to R be such that every solution of d square y by dx square plus 2k into dy by dx plus ly equal to 0 satisfies limit x tends to 0 y of x equal to 0. Then what are the values of L and K? What are the conditions for L and K? We have to find out. Now d square y by dx square plus 2k into dy by dx plus ly equal to 0. That is d square plus 2kd plus L of y equal to 0. Now here to identify the conditions, limit x tends to 0 y of x equal to 0. Limit x tends to 0 y of x equal to 0. This condition is satisfied only when the roots are negative real roots. Whenever roots are negative real roots, then limit x tends to infinite, limit x tends to 0, y of x value will be 0. That's why I am going to verify that condition. Now discriminant b square minus 4ac means 2k whole square minus 4 into L into 1, that is 4k square minus 4L. 4k square minus 4L, that is 4 of k square minus L. 4 of k square minus L. This is equation 1. Next, from this you can write minus b plus or minus b square minus 4ac by 2a logic. Based on that, I am going to find out discriminant value. d2 equal to minus b. Minus b means minus 2k plus or minus square root of b square 4k square minus 4L by 2a 2. After cancellation, this will become minus k plus or minus square root of k square minus L. Called it equation 2. Here equation 1 must have negative real roots. Equation 1 must have negative real roots. Now when it is possible, if it is real when k square minus L greater than 0, then for negative values of d1 and d2, k less than 0 and L greater than 0, or K square minus L greater than 0 and K less than 0. This is one case. K square minus L greater than 0 and K less than 0 is one case. Another case is K square minus L greater than 0 and K, I have written K square minus L greater than 0, K less than 0, first condition. Second condition is if K square minus L less than or equal to 0 and K greater than 0. In both the cases, we are going to get negative real roots. Therefore, second option as well as third option. Second option as well as third option. B and C both are correct. Next problem. Sin 2x into dy by dx plus 2y equal to 2 cos x. Y of pi by 4 equal to 1 minus root 2. Then which of the following statement is true? Now, the given differential equation is sin 2x into dy by dx equal to 2y plus 2 cos x. Y of pi by 4 equal to 1 minus root 2. Now, dy by dx equal to, you can write in standard form, that is sin 2x into dy by dx minus 2y equal to 2 cos x. This can be written as dy by dx minus 2 by sin 2x into y equal to 2 cos x by sin 2x. Dy by dx minus 2 by sin 2x is 2 by 2 sin x cos x into y equal to 2 cos x by sin 2x can be written as 2 sin x cos x. That can be written as continuation dy by dx minus y by sin x cos x equal to 2 cos x by 2 cos x cancel, 1 by sin x. Called it equation 1. It is a linear differential equation. We have to find out integrating factor. The integrating factor is e power integral p dx. So what is p here? Minus 1 by sin x into cos x dx. This can be written as e power minus integral 2 by sin 2x, that is e power minus 2 into 1 by 2 log tan x, that is nothing but e power minus log tan x, that is e power log tan x power minus 1, that is 1 by tan x, that is 1 by tan x. Integrating factor is 1 by tan x. Continuation. Therefore, the solution is y into if equal to integral q into if into dx. Y into 1 by tan x equal to integral q is 1 by sin x into 1 by tan x dx. That is integral 1 by sin x into 1 by tan x is cosec x into cot x dx. That is minus cosec x plus c. So y is equal to minus cosec x into tan x plus c into tan x. Continuation. This can be written as y is equal to cosec x into tan x can be written as minus secant x plus c tan x. That is called equation 2. They have provided one boundary condition, y of pi by 4 equal to 1 minus root 2. Therefore 1 minus root 2 equal to secant pi by 4 is minus root 2 plus c. Therefore c is equal to 1. The value of c is 1. Therefore y is equal to minus secant x plus tan x. Minus secant x plus tan x. Called it 3. Now at x is tending to 0, what about y? When x is tending to 0, y is tending to minus 1. Suppose when x is tending to pi by 2, y is tending to 0. Therefore, in this problem, in the options, when x tends to 0, y tends to minus 1. When x tends to 0, y tends to minus 1. When x tends to pi by 2, y tends to 0. X tends to pi by 2, y tends to 0. And when x tends to 0, y tends to minus 1. So, option C is correct. Option D is also correct. Therefore, correct answers are C and D. Because they have given the solution is bounded when x tends to 0. The solution is bounded when x tends to pi by 2. Because when x tends to 0, the solution is y equal to minus 1. When x tends to pi by 2, that y is tending to 0. That's why the solution is bounded in both the cases. Third option and fourth option, both are found correct. Next problem. The initial value problem, y dash equal to root y, y of 0 equal to alpha, alpha greater than or equal to 0. Y dash equal to root y. Y of 0 equal to alpha, alpha greater than or equal to 0. Y dash equal to root y. Sagar, homogeneous function of same degree, both are same. In the case of homogeneous function or homogeneous function of same degree, both are same. When you talk about whether the function is with degree n, okay, that is not related to this topic at any cost. That is a topic which is in Euler's theorem. Homogeneous function of degree n we are going to use. degree of each and every term is same, that is called homogeneous function of same degree. Okay, that is nowhere related to this one. dy by dx equal to root y. dy by dx equal to root y. From this you can write dy by root y equal to dx. Take integration on both sides. Integral 1 by y power 1 by 2 dy is integral dx. That is y power 1 by 2 by 1 by 2, that is x plus c. Continuation. 2 into y power 1 by 2 equal to x plus c. Squaring on both sides, you will get 4y. 4y equal to x plus c whole square. 4y equal to x plus c whole square. Or otherwise, you can write like this. Two into y power 1 by 2 equal to x. From this, you can write 4y equal to x square. 4y equal to x square. Understood? Now 4y equal to x square. Called it equation 1. Called it equation 1. Now either 4y equal to x square or 2 into y power 1 by 2 equal to x, both are correct. Now when alpha equal to 0, here we have two conditions. Alpha greater than or equal to 0. It is not my assumption, it is given in the data. Alpha greater than or equal to 0. Suppose alpha equal to 0, then what happened? Suppose alpha equal to 0, then you will get two solutions. What are the two solutions? Since y equal to 0 and y equal to x square by 4. When alpha is 0, y equal to 0, and when alpha equal to 0, y equal to x square by 4. You have two solutions because the problem is designed that y of 0 equal to alpha. Therefore, when x is 0, y is alpha. So, if alpha equal to 0, y is also 0. That is one solution. So, another solution is y equal to x square by 4. This is condition of option A. Option A is found correct. Next, suppose alpha greater than 0, then what happened? If alpha greater than 0, then y equal to 0 is not a solution, because if you put x is 0 here, x is 0 here, y is not 0, y is alpha. That's why y equal to 0 is not a solution. If alpha greater than 0, y equal to 0 is not a solution. Now I am going to verify. 2 into y power 1 by 2 plus 2 into y power 1 by 2 equal to x plus c. X plus c. So here y of 0 equal to alpha, if you substitute 2 into alpha power 1 by 2 equal to 0 plus c. C equal to 2 into alpha power 1 by 2. Now substitute here. You will get 2 into y power 1 by 2 equal to x plus 2 into alpha power 1 by 2. From this, y power 1 by 2 equal to 1 by 2 of x plus 2 alpha power 1 by 2 squaring on both sides. Y is equal to 1 by 4 of x plus 2 alpha power 1 by 2 whole square. So in this case you will get unique solution. One and only one solution. Therefore option C is also correct. So option C is correct as well as option A is correct. So both A and C are found correct. Next problem. X into dy by dx plus y equal to x for 0 less than x less than 1. Which of the following are correct? Now, x into dy by dx plus y equal to x. X into dy by dx plus y equal to x. Now, x dy plus y dx by dx equal to x. X dy plus y dx equal to x dx. X dy plus y dx is nothing but differentiation of xy equal to x dx. Now take integration on both sides. Integrate this. You will get integration of differentiation of xy is xy. Integral x dx is x square by 2. Integral x dx is x square by 2 plus c. Now y is equal to x by 2 plus c by x. X by 2 plus c by x. This is the solution. Now here suppose c equal to 0. Suppose let c equal to 0. Then what happened? Y is equal to x by 2. Suppose let c equal to root plus 2. Then if you take c equal to plus 2, then y equal to x by 2 plus 2 by x. Suppose c equal to minus 2, then y is equal to, in this case y equal to x by 2 minus 2 by x. Sir, why you are taking c value 0, c value 2, c value minus 2? Here c is arbitrary. That's why I have taken different values, because in the given options, which option is suitable, to identify that I have taken first c is 0, next c is 2, next c is minus 2, like that. We found that when c is 0, first option, when c is 2, second option, when c is 3, c is minus 2, we got third option. Fourth option is not possible, so D is incorrect. So A, B, C are possible solutions for different values of C in this problem. That's why first three options are found correct. Next problem. Let x of t and y of t, x of t comma y of t satisfies for t greater than 0, dx by dt equal to minus x plus y, dy by dt equal to minus y, x of 0 equal to y of 0 equal to 1, then x of t is. Now first I am taking dy by dt equal to minus y. Observe carefully. dy by dt equal to minus y. From this you can write dy by minus y equal to dt, dy by y equal to minus dt. By taking integration on both sides, integral 1 by y dy equal to integral minus dt, that is log y equal to minus t plus c. Log y equal to minus t plus c. Otherwise you can write log c also, no problem, because anyhow it is arbitrary constant, we can write log c. Now log y minus log c equal to minus t, log y by c equal to minus t, y by c equal to e power minus t. So y equal to c into e power minus t, y is equal to c into e power minus t. That is one solution we got. Now given the boundary condition as y of 0 equal to 1, therefore I am applying the boundary condition here. Y of 0 equal to 1, therefore 1 is equal to c into e power 0, therefore c equal to 1, therefore y is equal to, if c is 1 then y equal to e power minus t, e power minus t. This is one solution. Next, another differential equation is provided, dx by dt equal to minus x plus y, equal to minus x plus y, dx by dt plus x equal to y, dx by dt plus x equal to y is nothing but just now you have calculated e power minus t, e power minus t, called it equation 2. Now if you compare with standard form, it is linear, dx by dt plus px equal to q form. So here p is 1, q is e power minus t. Now integrating factor is e power integral 1 dt e power t. The solution is x into if equal to q into if into dt, x into e power t equal to q. What is q here? E power minus t into e power t dt, that is integral dt, that is t plus c. From this we can write x is equal to t plus c into e power minus t. Now x of 0 is 1, that is 1 is equal to 0 plus c into e power 0, that implies c equal to 1. Therefore x is equal to t plus 1 into e power minus t, t plus 1 into e power minus t. Same solution you can write in this manner, t into e power minus t plus e power minus t. So this can be written as x equal to t into e power minus t plus y. E power minus t is nothing but y na, or otherwise you can write, depending on the options you can write suitable solution. Now when you come to the options, in the option Third option, you have e power minus t into 1 plus t, one solution. Observe, another solution is A. Look at A, e power minus t into y of t. Yes, here you can write this y of e power minus t, this e power minus t as y of t. So this can be written as x is equal to t into y of t plus e power minus t. So this is option C, this is option A. So both A and C are found correct in this problem. Both A and C are found correct. Next one, let y of x equal to, y of x is the solution of the differential equation x square into d square y by dx square plus 5x into dy by dx plus 4y equal to 0. Satisfying the condition y of 1 equal to 1 and y dash of 1 equal to 0, then e square into y of e is, it is a numerical answer type question. Now x square into d square by dx square plus 5x into dy by dx plus 4y equal to 0 means the differential equation is in Cauchy-Euler form. X square d square plus 5xd plus 4 of y equal to 0. Now x square d square means theta into theta minus 1 because it is in Cauchy-Euler form. In Cauchy-Euler form, x square d square is theta into theta minus 1. 5xd means 5 theta plus 4 of y equal to 0. Theta square minus theta minus 5 theta plus 4 of y equal to 0. That is theta square plus 4 theta plus 4 of y equal to 0. Now the auxiliary equation is m square plus 4m plus 4 equal to 0. Now m plus 2 whole square equal to 0. M is equal to minus 2 comma minus 2. Now the solution is y is equal to C1 plus C2Z, C1 plus C2Z into e power minus 2z. That is nothing but C1 e power minus 2z plus C2z into e power minus 2z. Continuation. Y is equal to C1 e power minus 2z is nothing but x power minus 2. C2 z means log x into x power minus 2. Because z is log x is e power z. That's why. Now this can be written as y is equal to C1 by x square plus C2 log x by x square, called it equation 1. Now boundary conditions are provided in the data. Y of 1 equal to 1, y of 1 equal to 1, 1 is equal to C1 plus C2 log 1 0 anyhow, therefore C1 equal to 1. Another boundary condition. Y dash of 1 equal to 0, y dash of 1 equal to 0. If I differentiate y I will get y dash equal to c1 by x square is nothing but c1 into minus 2 by x cube plus c2 into log x by x square. So denominator is x power 4, x square into 1 by x minus log x into 2x. Now boundary condition is y dash of 1 equal to 0, y dash of 1 equal to 0, y dash is 0 when x is 1. So minus 2 by 1 cube minus 2c1 plus c2 log 1 0, that term vanish. So this is called equation 2, this is called equation 3, this is called equation 4. From 2 and 4 we can get the values of c1 and c2. From 2 and 4 we can get the values of c1, c2. From 2 and 4 c1 is 1, c2 is 2. Therefore the solution is y is equal to 1 plus 2 log x into x power minus 2. So 1 plus 2 log x into x power minus 2. Now you have to find y of e. So y of e is 1 plus 2 log e into e power minus 2. That is 3 by e square. We have to find out e square into y of e. E square into y of e is e square into 3 by e square. E square cancel. The result is 3. Therefore the answer is 3 in this problem. Answer is 3. E square into y of e is 3. Next problem. CF कैसे निकालना? Complementary function is depending on roots. What are the roots? Roots are real and equal. If roots are real and equal, corresponding complementary function is c1 plus c2z e power minus 2z. You have three cases. Roots are real and equal, roots are real and distinct, roots are imaginary. This is roots are real and equal case. Now y of x be the solution of the differential equation d square y by dx square plus 5 into dy by dx plus 6y equal to 0, y of 0 equal to 1, dy by dx at x equal to 0 is minus 1, then y of x attains maximum value at x equal to. It is a problem designed on not only differential equations but also maxima and minima concept. Now x square d square xd plus 4 means it is Cauchy-Euler form. In Cauchy's Euler form, x is nothing but e power z. That implies z is nothing but log x. By taking this substitution, xd becomes theta. Xd equal to theta. Theta means d by dz. X square d square is nothing but theta into theta minus 1. So you have to convert the differential equation with variable coefficients in the form of constant coefficients. After that, we have to solve by constant coefficient procedure. Whatever solution you are going to get, that solution you have to write in terms of C1 plus C2, in terms of Z and Y. After getting the solution in variable Y and Z, you have to convert in terms of X and Y. If X is e power Z, X square is e power 2Z. X power minus 2 is e power minus 2Z. That's why in the place of e power minus 2Z, I have written x power minus 2. E power minus 2Z is x power minus 2. Same thing I have written here. That is the logic. Understood? Now, if y of x is the solution of the differential equation, then the function attains maximum value at x equal to now d square plus 5d plus 6. D square plus 5d plus 6 of y equal to 0. Boundary condition is y of 0 equal to 1, y dash of 0 equal to minus 1. That is given in the data. Now, here the auxiliary equation is m square plus 5m plus 6 equal to 0. M plus 2 into m plus 3 equal to 0. So m is equal to minus 2 comma minus 3. Therefore, the solution is C1 e power minus 2x plus C2 e power minus 3x. Called it equation 1. Now, y of 0 equal to 1. So 1 is equal to C1 e power 0 plus C2 e power 0. Called it 2. Next, another boundary condition is given on y dash. That's why I am going to differentiate equation 1 with respect to x. We will get dy by dx equal to or y dash equal to minus 2c1 e power minus 2x minus 3c2 e power minus 3x. Called it equation 3. Next, y dash of 0 equal to minus 1. Minus 1 equal to minus 2c1 e power 0 minus 3c2. Called it 4. Called it 4. Now, from 3 and 4, you have to get the values of C1 and C2. Minus 1 equal to minus 2C1 minus 3C2, that is equation 4. Equation 2 is C1 plus C2 equal to 1. By solving 3 and 4, we get C1 equal to 2, C2 equal to minus 1. So minus 4 plus 3 minus 1 you will get. Now 2 minus 1 equal to 1 you will get, right? Now therefore y is equal to C1 e power minus 2x. C1 is 2 into e power minus 2x. C2 e power minus 3x. C2 is here minus 1. So minus 1 e power minus 3x. That is equation 5. Now we have to find out y of x attains its maximum value at which value of x. So by taking equation 5 you have to apply the concept of maxima minima. Now y is equal to 2 into e power minus 2x minus e power minus 3x, called it 5. Now y dash is minus 4 into e power minus 2x plus 3 into e power minus 3x. When we equate y dash to 0, we get 3 into e power minus 3x equal to 4 into e power minus 2x. From this we can write e power minus 3x by e power minus 2x or 3 by 4 equal to e power minus 2x by e power minus 3x. From this you can write e power x equal to 3 by 4. E power x equal to 3 by 4. Therefore x equal to log 3 by 4. Therefore x equal to log 3 by 4 means minus 0.289. That is nothing but x equal to approximately minus 0.3. Approximately minus 0.3. So answer is minus 0.3. Anyhow, at x equal to minus 0.3, if you calculate y double dash, it will be negative, because minus 4 into minus 2, 8 will come, here minus 9 will come. The result is negative. Y double dash is negative. Therefore, the function attains maximum value at x equal to minus 0.3. Next problem. Now let y of x be the solution of the differential equation y double dash minus 2y dash plus y equal to 0. Y of 0 equal to 1. Y dash of 0 equal to 1. Then limit x tends to minus infinite. Y of x is, here the differential equation is d square minus 2d plus 1 equal to 0, right? Now the auxiliary equation is m square minus 2m plus 1 equal to 0. M minus 1 whole square equal to 0. M is equal to 1 comma 1. The solution is y is equal to c1 plus c2x of e power x. Now they have provided boundary conditions, that's why I am calling it as equation 1. Now y of 0 equal to 1 is the first boundary condition. So y of 0 equal to 1. So 1 is equal to c1. plus C2 into 0 e power 0. So finally C1 equal to 1. Next, y equal to C1 e power x plus C2x e power x, that is equation 1. If you calculate y dash, C1 e power x plus C2 into x e power x plus e power x. This is called equation. We have 1, so this is 2. Now, y dash of, another boundary condition we have, y dash of 0 equal to 1. Means 1 is equal to C1 e power 0 plus C2 into 0 plus e power 0. That is equation 3. Already you have C1 value. C1 is 1. Substituting C1 equal to 1 in equation 3, we get C2 equal to 0. Since C1 equal to 1, that's why C2 equal to 0. Therefore, y is equal to C1 e power x. C1 is 1. That's why 1 into e power x. E power x. Anyhow, C2 is 0. This is y of x. We have to find out limit x tends to minus infinite, y of x is limit x tends to minus infinite, e power x is. When x is tending to minus infinite, e power x is e power minus infinite, that is 0. So the answer is 0. Understood? Next problem. Next, dy by dx equal to sin 2x into y power 1 by 3, y of 0 equal to 0 is R. It is MSQ. dy by dx equal to sin 2x into y power 1 by 3. dy by y power 1 by 3 equal to sin 2x dx. That can be written as integral y power minus 1 by 3 dy equal to integral sin 2x dx. Integral y power minus 1 by 3 can be written as y power minus 1 by 3 plus 1 by minus 1 by 3 plus 1 equal to integral sin 2x minus cos 2x by 2 plus c, that is 3 by 2 into y power 2 by 3 equal to minus cos 2x by 2 plus c. Now called it equation 1. Here y of 0 equal to 0, that is the boundary condition. If you apply the boundary condition y of 0 equal to 0 here, you will get 0 equal to minus 1 by 2 plus c. Therefore c equal to 1 by 2. The value of c is 1 by 2. Therefore 3 by 2 into y power 2 by 3 equal to minus cos 2x by 2 plus 1 by 2. Now continuation. 3 by 2 into y power 2 by 3 equal to 1 minus cos 2x by 2. 1 minus cos 2x by 2 is nothing but sine square. Here 1 minus cos theta can be written as 2 sine square theta, that is 2 sine square x by 2 plus c. So 3 by 2 into y power 2 by 3 equal to sine square x plus c. Sine square x plus c. From this you can write here. Already we have applied the boundary condition, therefore you need not write c. After applying the boundary condition only we got 1 by 2, right? And now from this you can write y power 2 by 3 equal to two sine square x by 3. Now raise power 3 on both sides, you will get y square equal to 2 cube 8, 3 cube 27, sine square x whole cube. Now y square equal to 8 by 27, sine square x whole cube is sine x whole power 2 whole power 3, that is sine power 6x. Now this is y square. Now if you calculate y, you will get y is equal to plus or minus square root of 8 by 27. If you take square root for sine power 6x, you will get sine cube x. So y is equal to square plus or minus square root of 8 by 27 sine cube x. So when you come to the options, y is equal to plus or minus, so minus 8 by minus square root of 8 by 27 sine cube x plus 8 by 20 square root of 8 by 27 sine cube x, as well as when sine x is 0, y of x is 0. So first option is true, second option is true, third option is also true. So first three options are found correct. Anyhow, last option is incorrect. So A, B, C are possible solutions for the given equation. Now y1, y2 and y3, y1, y2, y3, actually y1, y2, y3 be the linearly independent solutions of the differential equation. Then you have to find linearly independent solutions of the differential equation. Then if the Wronskian is in the form of k into e power bx, then what is the value of b? So first you have to find independent solutions. With the help of independent solutions, you have to calculate Wronskian. After calculation of Wronskian, you have to compare whatever Wronskian you are going to get, that one you have to compare with k into e power bx. By comparison, you can get the value of b and k. Okay, the problem is designed on b. Okay, right. Now the differential equation is d cube y by dx cube minus 6 into d square y by dx square plus 11 into dy by dx minus 6y equal to 0. D cube minus 6d square plus 11d minus 6 of y equal to 0. Now we have to find out the roots. Observe here, if you calculate the roots, this can be written as d minus 1 into d minus 2 into d minus 3 of y equal to 0. So here the roots are 1, 2, 3. Therefore the solution is, roots are real and distinct. Therefore the solution is y is equal to c1 e power x plus c2 e power 2x plus c3 e power 3x. Independent solutions are nothing but coefficients of arbitrary constants. These are called independent solutions. The independent solutions are e power x, e power 2x, e power 3x. After finding independent solutions, you have to calculate Wronskian. What is Wronskian here? Wronskian is given by Wronskian of w1, y1, y2, y3 is nothing but, observe here, this is y1, this is y2, this is y3. That is given by a 3 by 3 determinant. You have to write y1, y2, y3, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. You have to calculate derivatives. Okay, y1, y2, y3, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. So you will get a determinant. In this determinant, y1, y2, y3, y1 is e power x, y2 is e power 2x, y3 is e power 3x. Differentiation of e power x is e power x. Differentiation of e power 2x is 2 into e power 2x. Differentiation of e power 3x is 3 into e power 3x. Differentiation of e power x is e power x. Differentiation of 2 into e power 2x is 4 into e power 2x. Differentiation of 3 into e power 3x is 9 into e power 3x. Now we have to expand determinant. Before going to the expansion, I am going to take e power x common from first column, e power 2x common from second column, e power 3x common from third column. From here I am taking e power x common, from here I am taking e power 2x common, from here I am taking e power 3x common. I will get e power x into e power 2x into e power 3x of determinant 1, 1, 1, 1, 2, 4, 1, 3, 9. Continuation. That is equal to e power x into e power 2x into e power 3x is e power 6x. One, 1, 1, 1, 2, 4, 1, 3, 9. Now we have to expand determinant. E power 6x of 1 of 18 minus 12 minus 1 of 9 minus 3 plus 1 of 4 minus 2, that is e power 6x of 18 minus 12, 6, 9 minus 3, 6 minus 6, plus 4 minus 2, 2. Final result is 2 into e power 6x, 2 into e power 6x. So what we have to do? We have to compare this result. This is Wronskian of w1, y1, y2, y3 equal to 2 into e power 6x. 2 into e power 6x. Now observe. What is Wronskian here? K into e power bx. Given that Wronskian is w of y1, y2, y3 is k into e power bx. Now compare. If you compare these two equations, you will get the value of k is 2, the value of b is 6. In this problem, did they question k value or b value? They have questioned. In this problem, they have questioned b value. You have to find b value. Understood? What is b value in this problem? We found that the value of b is 6. Therefore, answer is 6. Understood? Yeah, b value is 6. Any queries? Linearly independent solution. Okay. First we have to find out the roots. From the auxiliary equation you can find out the roots. So here d minus 1, d minus 2, d minus 3. Therefore 1, 2, 3 are the roots. 1, 2, 3 are the roots. Therefore roots are real and distinct. When roots are real and distinct, complementary function is c1 e power x plus c2 e power 2x plus c3 e power 3x. c1 e power m1x plus c2 e power m2x plus c3 e power m3x. Okay, that's why the coefficients of arbitrary constants c1, c2, c3 are known as independent solutions. So here e power x, e power 2x, e power 3x are independent solutions. So what we have to do? With the help of these independent solutions, you have to write Wronskian. So in Wronskian, y1 is nothing but e power x, y2 is nothing but e power 2x, y3 is nothing but e power 3x. So you have to write y1, y2, y3. After that, first 3 independent variables you have, 3 independent solutions you have. Therefore compulsory Wronskian is a 3 cross 3 determinant. No. For 2 independent solutions, Wronskian is udv minus vdu. If you have 3, then compulsory you will get a 3 cross 3 determinant. Understood? Sagar. If you have 2 independent solutions, then Wronskian is one independent solution you can say u, another independent solution you can say v. Suppose you have c1 cos x plus c2 sin x. You can say cos x is y1, sin x is y2. When 2 independent solutions you have, your Ranskin is a 2 cross 2 determinant. y1, y2, y1 dash, y2 dash. You are going to multiply y1 with y2 dash and y1 dash with y2. Just by determinant value, you can get Ranskin. That is for 2 cross 2. But in the case of 3 cross 3, because 3 independent solutions comes, compulsory Ranskin is a 3 cross 3 determinant. Then you have to write first solution y1, second solution, third solution, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. You have to expand determinant, because in 2 cross 2 it is possible to calculate AD minus BC technique, but in 3 cross 3 compulsory you have to expand the determinant. Understood? So y1, y2, y3 are nothing but independent solutions. What are y1, y2, y3? Coefficients of C1, C2, C3 in the solution of the given differential equation. Now, Unacademy is introducing new subscription plan for 18 months for ESE and GATE, ISRO, BARC and PSU examinations. In Plus subscription you have daily practice problems, weekly monthly tests, separate doubt clearing sessions, live and interactive lectures, unlimited access by taking one subscription. Use code KUR75 to get Plus subscription. You have 1 month subscription, 3 months, 6 months, 12 months, 18 months, 24 month subscriptions are available. Thank you. Next session will be on partial differential equations, Monday evening at 9 p.m. Thank you.